We're starting with Unit 1, Fractions, Lesson 1, Factoring. We're going to start with a definition, okay? So, factors are numbers we can multiply together to get another number. Here's an example. 2 times 4 equals 8. So 2 and 4 are factors that give us the product 8. And I'm actually going to write this definition in one other way, okay? So we can just get another idea. So a factor is a whole number that can evenly divide another number. So it's actually kind of the same thing. But if you think about it, think of an example here. Say that the whole number that say that the number that I'm starting with is 12. If I want to use the number 6, is there a number that I can multiply by 6 to get 12? Yes, it's 2. So you could say that 12 divided by 6 gives us 2, meaning that 6 is a factor of 12 because 6 evenly divides 12, and then you just get the number 2, okay? So let's take a look at some factors here. So factors of 8. So we can just list them out. Things that multiply to give us 8. So that would be 1 and 8, 2 and 4. How about 100? 1 times 100, 2 times 50, 3 doesn't go in, 4, think about quarters, so 4 times 25, 5 goes in, it's actually 20 times, 6, nope, 7, nope, 8, nope, 9, nope, 10, and 10. And then you can see it kind of wrapped around. So like if we were to list this underneath, it wraps around. Okay. Factors of 36. 6 times 6 is the first one that my mind comes up with, right? How about 1 and 36? Maybe 2 and 18? 3 and 12? 4 and 9? 5 doesn't work. We already did 6. 7 doesn't work, and neither does 8. So I think that's all. Factors of 11. I mean, 1 times 11 works, but there's literally nothing else. That's because 11 is a prime number. So we say that a number is prime if it can only be evenly divided by 1 and itself. So let's list some other prime numbers. There's a bunch of options here. So we can do, let's see, 2 is a prime number because it's 1 times 2. 3 is 1 times 3. 4 won't work. 5 works. 7 works. I'm going to skip a few. 13. 29. And we could just kind of keep going. There's lots of options here. So maybe 53. And then, you can list more. Our next definition is greatest common factor. And actually, it's nice to abbreviate this because it's kind of long. So we can call it GCF. And here's the definition. The GCF, greatest common factor, of 2 or more numbers is the largest factor that they share. So So let's try some examples. So we've got 15 and we've got 60. We need to find factors that they share. So to do this, we have to actually have a list of factors. Otherwise, it's really hard to find something that's in common. So what I'm going to do is I'm going to write 15 here, okay? And I'm going to write 60 over here. And underneath each one, I'm just going to list factors. I don't think we did either of these up here already. We didn't. So let's start with 15. 1 times 15. 2 is not going to go in because it's an odd number. 3, yep, 3 and 5. So you're thinking of your math facts for 15. 4 doesn't work. 5 we already did, so we're good. That's it. How about 60? 1 times 60. 2 times 30. 3 times 20, because if you check, 3 times 2 makes 6. And then just add a 0, now it's 60. What about 4? This one actually has to do with time. 4 and 15 make 60. And 5 works too. 5 and 12. And so does 6. 6 times 10. 7 doesn't, and neither does 8 or 9. So we're done. So let's see. Oh, I see one that's in common. I hope you see it too. So I see that they both have 15. So that means that the answer here, the GCF, is 15. Okay? Let's try 20 and 16. Make your two lists. So 20 and 16. And just go in order. 1 times 20. 2 times 10. 3 doesn't work. 4 times 5. And then we've already wrapped around. Because I can say 5, but I already wrote it. 1 times 16. 2 times 8. If you need a multiplication chart, that would be really helpful for this. 3 doesn't work, and then we get 4 times 4. So that was it. Let's see, anything in common here? They both have a 1, they both have a 2, they both have a 4, and then nothing else matches. So the biggest match is just 4. So we say GCF is 4. Last one, 18, 24, and 60. If you're really paying attention, we already did the factors of 60 over here. So I'm not going to rewrite them. 18, 24, and I'm actually just going to copy these guys and just paste them here so we don't have to do it. Technology, right? All right, so 18. That's going to be 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work. We already said 6. Okay, let's try 24. 1 and 24, it's even, so 2 and 12, 3 and 8, 4 and 6, and then 5 doesn't work, and we already said 6, so that means we're done. Okay, let's check. So I'm just going to erase this little pink because we don't know that yet. We need something that's in common in all of these. They all have 1, they all have 2, they all have 3. They don't all have 4, but they do all have 6. So maybe it's 6. Let's keep looking. I don't see a 9 in the other ones or an 18. I don't see an 8 matching. Yeah, I think it's got to be 6. There's our final answer. Next up, we're going to look at a word problem for GCF, okay? And you can tell that this is for GCF by something that's in the last sentence. So I'll get to that in a second. Kiara baked 24 oatmeal cookies and 40 chocolate chip cookies to bring to the bake sale. She wants to divide them into containers with the same number of each kind of cookie in each container. What is the greatest number of containers she can fill? So I'm just going to also use the squiggly underline, and I always do that right on the question. So literally the part with the question mark, okay? These are called annotations, and we use them to mark up a math problem so that we can solve it, okay? So I circled the numbers, and I underlined some really important keywords. And in my graphic organizer here, I'm going to pull in that information. So what I know. Well, 24 oatmeal cookies. I'm not going to write cookies. It's fine. 40 chocolate chip. And I'm just putting CC. Okay? And we want to split them up. So we're trying to do some kind of process of like splitting them up evenly. So I'm just going to put a note here. Split up evenly. But actually, the key word that I really like is in the part that I squiggly underlined, the question. It says greatest number. That right there is definitely a key word for GCF, greatest common factor. So if you ever see that in the question, you know it's GCF. So we just need the GCF of 24 and 40. And we'll go kind of quick because we actually already did some of these. 40 is 1 times 40, 2 times 20, 3 doesn't work, 4 times 10, 5 times 8, and that's all that works. We need the biggest one that matches. 1, 2 matches, oops, 3 doesn't match, 4 matches. I don't see a 6. Oh, there's an 8. I don't see a 12, and I don't see a 24. So remember, it's GCF, so we have to change that. It's actually going to be 8. So the greatest number of containers she can fill is 8. What does this really mean? Well, it means that she's going to have 8 containers, okay? Each container is going to have 3 of the oatmeal cookies, and each container is going to have 5 of the chocolate chip cookies. Okay? Now, why did we do this? Well, this is actually really useful for dealing with fractions, okay? So we're actually going to take a look at how to apply this to making equivalent fractions or like simplifying fractions. Things that you've already done before, okay? Find the GCF of the numerator, the top number, and the denominator, the bottom number, okay? And what we're going to do is we're going to make a 1 by factoring out the GCF, okay? Simplify using factoring. So we're going to apply this, and it will make more sense after I show you what I mean by factoring out a 1, okay? So take a look at this 10 and this 15. We need something that goes into, multiplies to a 10 and to a 15. If I wasn't sure, I would pull out a multiplication chart right now that does like all the math facts. But I know that these both happen when I count by 5s, because if I say 5, 10, 15, right? So they both actually share a 5. So I'm going to write it like this, okay? 10 would be the same as 5 times 2. 15 would be the same as 5 times 3, okay? So now, this is what I meant about the 1. Do you see the 5 over 5? That's just equal to 1. So our answer here is 1 times 2/3. Well, 1 times anything is just that thing. So this is just 2/3. Okay? And let's look at just one more of these. We'll look at number 10. 21 over 36. We need something that they both share. If I checked a math facts chart, I'm sure I could find it. So I think it's going to be 3 and 3. Remember, we're making a 1, so we need the same number on the top and the bottom. 21 is 3 times 7. 36 is 3 times 12. And remember, that 3 over 3 right there, that's just 1. So this is 1 times 7/12, or just 7/12. And we know we're done on this one because 7 and 12 don't share any factors. Like there's nothing we could think of that multiplies into 7 and into 12 other than 1. So we know we're done. And I am going to actually save this question right here as part of our warm-up for Monday. Okay? So you'll see that one again. Okay? And just right here at the end, why do we simplify fractions? I'm going to have you guys answer that right now in the Edpuzzle, okay?